Hello everyone. In the previous video we discussed introduction of Boolean Algebra. Continue with that. In this video I will be discussing different Boolean theorems. So first let's consider the single variable and function. And here the first theorem is x dot 0 equal to 0. And here dot represents the logical and function. And this is the symbolic representation of logical and function. So here one input is x and another input is 0 and the output is always 0. So here I written the truth table. X and y are the two inputs for this AND gate and z is the output. So here y input is always 0, you can see here, and x can have either 0 or 1. So let's consider first x value 0. So 0 dot 0 equal to 0. Just multiply this x and y values. 0 into 0 equal to 0. And next consider x value 1 and y value is already 0. So 1 into 0 equal to 0. So now consider the output column, that is z. In both the cases the output is 0. That means irrespective of the value of x, the output is always 0. Hence x dot 0 equal to 0. So next second theorem, x dot 1 equal to x, and here one input is x and another input is always 1. So let's consider this truth table. X and y are the two inputs, z is the output, y is already 1 and x can have two different values, 0 or 1. So let's consider x value 0. So 0 into 1 is 0 and 1 into 1 output is 1. So now consider this output column z. If x is 0, the output z is 0. If x is 1, the output z is 1. That means the output is always x value. Hence x dot 1 equal to x. So next theorem 3, x dot x equal to x. So here now both the inputs are x and output is always x value. So that means here x value is 0, y value is also 0 because now y is nothing but x. So 0 into 0 output is 0, and if x value is 1, 1 into 1 is 1. If you consider the output column z, in both the cases, if the x value is 0, output is 0. If the x value is 1, output is 1. Hence x dot x equal to x. Next theorem 4, x dot x bar equal to 0. So here one input is x and another input is complement of this variable, that is x bar. So here now y is x bar. So x value is 0, y value is x bar. So x bar is nothing but complement of this. So that is 1. So 0 into 1 is 0. And next consider x value is 1. So x bar is nothing but 0. So that is 1 into 0 equal to 0. So now if we consider the output column z, in both the cases output is 0. Hence x dot x bar equal to 0. So next we will consider single variable or function. So the first theorem is x plus 0 equal to x. So here plus represents the logical OR function, and this is the symbolic representation of logical OR. So one input is x and another input is 0, and output is always x value. So if you consider this truth table, so here y input is, it is always 0, and x can have two different values, either 0 or 1. So let's consider first x value 0. So 0 plus 0 equal to 0. And next consider x value 1. 1 plus 0 equal to 1. So now consider the output column z. If x value is 0, z value is 0. If x value is 1, z value is 1. So that means the output is always x value. Hence x plus 0 equal to x. Next theorem, x plus 1 equal to 1. So here one input is x, another input is always 1. So let's consider this truth table. Y value is always 1, and x can have two different values, either 0 or 1. So let's consider first 0. So x 0, y 1. So 0 plus 1, 1. And next consider x value 1. 1 plus 1, output is 1. So here actually plus is nothing but it's a logical OR function. So in logical OR function, 1 plus 1 is always 1. It's not binary addition. So in the binary addition, actually 1 plus 1 equal to sum 0 carry 1. But this is the logical OR function. Hence 1 plus 1 is 1. And now consider the output column z. So in both the cases, the output is 1. Hence x plus 1 equal to 1. So next, x plus x equal to x. Here both the inputs are same now, that is x. If you consider the truth table, x is 0, y is also 0, because y is nothing but now x. So output is 0. 0 plus 0 is 0. So if x is 1, y is also 1. So 1 plus 1 is 1. So that means if x is 0, output is 0. If x is 1, output is 1. Hence x plus x equal to x. And next, x plus x bar equal to 1. So that is one input is x, another input is x bar, that is complement of this variable. So let's consider this table. X is 0 and y is 1, because y is nothing but x bar now. So 0 plus 1 is 1. And next consider x1, and y becomes 0 because y is nothing but x bar. So 1 plus 0 equal to 1. So now if you consider the output column, that is z, in both the cases output is 1 only. Hence x plus x bar equal to 1. So next we'll consider single variable invert or not function. So here x double bar equal to x. So already we know that x single bar is nothing but complement of that variable, or in other way it's a not function. So here this is the symbolic representation of inverter or not gate. So the input for this is x, the output of this gate is x bar, that is it's a complement of this input variable x. And here one more NOT gate, that is the output of the first NOT gate is connected to input of the second NOT gate. That means one more time we are complementing this x bar. So already it is x bar. The output of this second NOT gate is x double bar, and that is equal to x. Let's consider this truth table. Here x and x bar, x double bar. If x is 0, x bar is 1. That is complement of this 0 is 1. And x double bar is again complement of this 1 is 0. And next consider x equal to 1. Complement of this 1 is 0. That is x bar equal to 0. And take one more complement. This 0 becomes 1. That means x double bar equal to 1. So now consider this x column and x double bar column. So if x is 0, x double bar equal to 0. If x is 1, x double bar equal to 1. That means x double bar equal to x only.